The following content has been provided by RWTH Aachen University.
So those steps in a little more detail, we just heard red versus green buttons as an example. Another example would be to say, I think it's faster to select menu items when I arrange them as a pie menu, a circular one, rather than the traditional linear menu. That could be another claim as a hypothesis. Next thing then is to design the experiment and pick the variables and your the fixed parameters. So we would, in this case, say the thing we want to change in a controlled fashion is the type of menu, pi versus linear. That's the variable that changes. It only has two values, pi or linear, but that's the variable that changes. And what would result out of that would be that we think that finding an item in these menus, so seeking a target in these menus, would be faster with one than the other. So changing the target seek time would be the outcome of what happens. Then you would run a pilot study to debug the experimental procedures. For example, you might have to make sure that the targets you put into your menu are sort of well balanced, that there is no obvious bias for one or the other design in your experiment. I should point out that this example we're using here is simplified from an actual paper by Callahan and colleagues at CHI 1988, where they actually did that kind of study. So if you want to learn more about what they did here, you can look at their actual paper that went through all these steps in much detail. And they found, for example, that they had to improve the distribution of menu targets when they're doing the pilot. Next thing is you recruit subjects. In their case, back in '88, they said they looked for undergraduate students that had little or no mouse experience. Well, that won't work today. So you would have to, you'd have to keep in mind that you need to have a group of people where you have no uncontrolled variables that are floating around too much, right? So the experience that these people have should be maybe consistent, for example, so that you don't end up with one group having played with computers a lot and then the other group hasn't. To avoid impact and noise and things that mess up your data. Then you run your experiment. In this case, each participant had to perform menu selections 10 times for each type of menu. That was the experiment. And then you have to interpret the results to accept or reject the hypothesis. In this case, the experiment by Callahan found that the mean seek time, the target variable they were looking for, the dependent variable they were looking for, was 2.26 seconds for a pi menu versus 2.64 seconds for linear menu. So there seems to be a significant speed up, especially because the difference was statistically significant with a fairly low p-value. And that, if that doesn't mean anything to you, it will after reviewing your favorite statistics class. We won't be going into too much detail on that here. But that is definitely something you will need a lot in running HCI sort of experiments. So a couple things about the subjects you pick. One question that comes up a lot is, what should my people be like? Where do I find my subjects? The easiest subject to find is the person sitting next to you in this class. That's a very common choice to pick people from your own field of work. And that's why people sometimes joke the best studies group of people in the history of mankind are undergraduate psychology students, because they are always taken as subjects for all the experiments that all the universities need to run to write their papers. And that's probably true. And we often also do studies in that kind of where we just ask students to do the experiment for us, which is fine if we're studying something where we don't assume that people like you, undergraduate or graduate computer science students or related subjects, are going to be significantly different from the average population. Right? If we did a study on the understandability of a programming language, then you would be a very specific kind of user base that is very different from the average person out there. So keeping in mind, how well do people know the system? How well do they know the domain? How well do they know computing in general? Age, educational background, those kinds of things need to be kept in mind when you run those studies. At least you should report them so that others who pick up that study, maybe to learn something from it, know the limitations of who actually was recruited for subjects. And then the big question, how many? It's always hard to find people, and every additional user is going to be a bother to find and recruit and instruct, and it takes more time to run studies with more people. But it's important because of statistical significance. If I only run a study with one person and he gets along great with the system, that's completely random, right? I don't know why that happened, right? I can't really predict anything from that. If I do it with 10 people and all of them are much faster using pi menus than linear menus, then something's going on. And we can prove what is going on by using statistical analysis. Basically, the finer the details are that you want to measure, that you want to prove, the more people you will need in order to make that measurement possible with statistical significance, so it's actually reliable in, as far as statistics can be providing reliable results. If you want to know exactly how many people you need to find a result of a certain confidence, there's never going to be 100% reliability, of course, because it's statistics. But if you want to have a certain confidence that your result is correct, then the so-called statistical power analysis, which is a mathematical method, will tell you how many people you will need in order to arrive at a result of a particular confidence level. What kind of variables are we dealing with? Well, we already mentioned things like pi menu versus linear menu. That's the independent variable. That independent means that you control it. It doesn't get changed by the experiment itself. You change it consciously. For example, the type of menu or number of menu entries could also be an independent variable. Not the one that you want to prove something about, but it could be another one that you need to vary to cover your main claim with a broader range of numbers. What do I mean? Well, you want to show pi menus are faster than linear menus? You can do that with 10 menu items. But then somebody might say, well, you showed it for 10, but what about 5 or 15 or 3? So if you do it for various numbers of menu items, and you always find that pi menus are faster than linear menus, then you've shown something more meaningful, because then it seems to really be true for a large variety of menu items, so it becomes a more general claim. Or if it's not true for all the kinds of menu numbers, you might be able to show something. Say short menus, pi menus are better. Long menus, linear menus are better. So we've learned something again. Each level of an independent variable, like pi menu, linear menu, or 5, 10, 15 menu items, is called a treatment in statistics. And the dependent variables are the ones that you actually measure. They are dependent on the independent variables, hopefully. At least that's what you're trying to show. So for example, the most common thing is execution time. How long does it take a person to do something with a system under a certain treatment? So that's execution time. Or error rates. How many mistakes do people make? And also you can ask people for subjective preference. That's also something you can measure and then quantitatively evaluate after that if you have enough people reporting that kind of data to you. So just because we're saying quantitative analysis doesn't always mean that you need to measure so-called objective physical values. You could also ask people for their opinion on a scale, and then report the things that you got back from these people. If you have enough data there, you can create a quantitative analysis of that data. That's perfectly fine. To give you an example for subjective preference issues, Bruce Tognazini, who was one of the people who designed the Mac user interface, ran an experiment at some point where he wanted to find out what keyboard shortcuts were actually bringing in terms of speed up. And it was interesting because he had a highly graphical task for people, and all the people said that they felt that using a keyboard shortcut was faster than using the menu item, for example, to, I don't know, select a different tool or to change something. But they found in their measurements that the menu selection was actually faster, which seems weird, doesn't it? Well, if you think about it, if you use the mouse for something, and then you move over and you have to do a two-handed keyboard shortcut, you're actually leaving the mouse alone, you move over to your keyboard, you type something, you go back to the mouse. That takes a lot of time. However, that time you basically ignore in your head. You don't notice it because you're busy doing the changing. So your brain is so busy doing that you don't really notice that it's going on. Versus selecting a menu is a very simple operation where you keep your hand on the mouse, you just move up there, you pick something, and that's actually fast if you're already doing a graphical task. Not if you're typing, because then you have to go to the mouse first. But if you're already doing a graphical task, that's pretty fast. However, people didn't feel that this was this wasn't keeping them very busy, so it felt to them that it was a slower task. The keyboard shortcut somehow felt very fast because I could trigger the command with a single keystroke, although it took me longer to get to that keystroke. So there are sometimes weird things going on in subjective preference versus the objective data that you observe. So let's do a little in-class exercise on these things. I would like you to identify the variables, the independent ones and the dependent ones, from each of the following scenarios, and what levels each independent variable would have. First example, we have a study that we want to do that wants to investigate whether people who have attended a security training program generate and use more secure passwords than people who haven't received any security training. Okay? So that's a hypothesis. And that hypothesis, we'd like to find the independent and dependent variables for. So what's the independent variable here? Yep.
Whether or not the people has attended the security training program.
Exactly. What's a dependent variable?
The number of secure passwords.
Number of secure or insecure passwords. For that, we would have to define what that means, right? So we'd have to have some meaningful characteristic that says, or a measurement of security of passwords. Yes?
Could you clarify the question, because I understood the more secure password not in terms of number of passwords, but in the complexity of.
Right. It basically just means that people generate and use more secure passwords. So more secure meaning
each individual password is more.
No, not a high. Yes. So not a higher number of secure passwords, but actually each password is more secure. So yeah, that's an interesting sort of different interpretation of English here that you can apply. So right, those are the things, and the levels we're looking at, or the treatments here that we'd have would be security training, yes, no, would be the two different treatments of the variable security training. Second example, here's a research team that examines the effectiveness of joysticks and trackballs for selecting static and moving targets. So first of all, what's the independent variable here? One's obvious, yep.
Whether the person uses a joystick or a trackball, whether the target is static or moving, and if they examine the effectiveness, maybe they want to compare it to some other device. I don't know what that means, examining the effectiveness, if they just want to compare joystick and trackball, or if they want to see if that's more effective than...
No. It refers to joystick versus trackball. So it's a battle of joystick versus trackball. Your joystick, your trackball, so these two are being compared. So those are the two things. So, but you're right. The obvious independent variable, because that's the one we really find interesting, is joystick or trackball. Right? That's the variable is basically the input device, and the two levels of the variable are joystick and trackball, or the two treatments that you would do. However, there's also, as we can see here, these guys were already a little, smarter. They said, we're not going to study that for targets that need to be acquired and clicked on or selected that are static, but we're also going to study that for things that move around on the screen. Right? Maybe there's something going on here for one versus the other. So that's another independent variable, whether the target is moving or not. We don't necessarily see that as the primary goal of this research. Probably originally was to find out whether joysticks or trackballs are better, but they're also expanding their question and making their question a little more detailed and a little more refined. And so they might find some interesting results. Maybe, for static targets, the joystick is faster. Maybe for moving targets, the trackball is faster. Who knows? Right? And if that's so, then that raises new interesting questions that people can do research on. What's the dependent variable? Yeah.
Either the time it takes them to target the target, or maybe the precision, like how far away they are from the center or whatever.
Exactly, and the or whatever. That's exactly one of the things that will, cost you many hours of actually coming up with the right depending variables and right ways of measuring them to actually get a result that's meaningful to you and that that works, that you can report, and that actually gives you something interesting as a result. But yeah, speed, accuracy, or both usually, it would be perfectly fine. And that's showing that when they said effectiveness, you can't measure effectiveness because it's not really well defined what that means. So we need to specify what that means, and we do that by saying speed plus accuracy or a mix of the two or something like that. Third one, a research team that examines whether virtual teams who use video instant messaging, IM, or FaceTime or Skype or whatever, are more productive than teams who use text-only instant messaging. Yeah.
The independent one is instant messaging, so text-only or video. And the dependent variable is the productivity, which has to be measured as the effectiveness, so how much is done or how fast it is done.
So that's where we're getting into the interesting part, because how do you measure productivity? That's a question that often comes up because a lot of people develop new interfaces to do certain tasks better, like productivity tasks, and coming up with ideas, writing proposals, whatever. And all of those have this challenge of how do I measure that my system is better? Well, I think it makes people more productive, but how do I show that? And so what would be an idea of measuring whether teams are actually more productive? Any thoughts? Yeah.
You could give the same task to both groups and then measure how much time they take to do the same.
To solve it. Okay, yeah. So if there is a task where it's clear when it's solved, you could measure the time to solve it. Yeah. Other ideas? Yeah.
Maybe you could look at how many projects they have completed within the last month or year, something like it, and compare it.
Yeah. If the project size is comparable, you could do that, or you could just measure. There's a measurement to find out how many distinct ideas are generated in a meeting, for example. You can do that by, again, careful word analysis, finding new concepts are being introduced into the meeting where somebody goes like, hey, what about, and so on. So that's one way to measure that. Or you could also look for user satisfaction. How did the teams feel they were, did they feel they were more productive or less productive? Not a fully reliable one, but it's an interesting thing as well.
This content was provided by RWTH Aachen University.